Frame, frames look okay. Got myself a cold brew. And I'm about to F some stuff up. I have no idea what I'm doing, but with the power of AI, I will program a game. What could possibly go wrong? Alright, let's see. Stream health. It's not too bad. It's not too bad. Let me test to see if the audio is working and everything. Let's see. Let's refresh this. I think it's laggy. Think it'd be laggy. Maybe not. Maybe not. Actually, I think it's good. I think we're good to go. Alright. Where do we start? So, I have Unity. I have Microsoft Visual Studio. And I have Gemini. All the things you need, realistically, I guess. So let's start. Let's ask Gemini. Alright. Let's make a new chat with Gemini. Alright. Hello. I don't need to say hello, it's an AI. Make a game on Unity version 6.1, and then I'll put in here 6000.1.14 F1 so it knows the version I'm using. I'm asking the AI. I want to make a game on Unity version 6.1 and gave it the version because the AI might get, you know, like, oh, I told you to do the thing for the other version using dots in ECS or maybe ECS and whatever to simulate an economy with individuals. So I'm doing the newer technology that came out this year, DOTS, data-oriented technology, and ECS, which is like 200 times faster, 50 times faster, because it uses multi-threading, which is nothing super new, but it also uses a burst compiler. So when it allows multi-threading and it organizes the memory of your program extremely efficiently. So I have no idea what I'm doing though. Don't look at me. I don't know what I'm doing. Let's see if the AI can help us. Alright, here we go. Whoops, I just closed all my windows. Oops. Alright. Stupid computer. Alright. That's an excellent and ambitious project. Using Unity's data-oriented technology stack, DOTS, and the ECS for large-scale economy simulation with many individual agents. You know, those guys with the dark sunglasses. Not those kind of agents. It's an ideal case. ECS is designed for high-performance, multi-threaded processing required for massive simulations. Cool. Oh, where's my, there it is. Let me just test here. Test. Cool. The chat does work. Just checking to see if it pops up. Alright, your simulation will be structured around 3 main ECS principles: entities, components, and systems. I love that. I love how that functionality works. If I can get it to work, it's been difficult for me, but I'm brand new. I'm doing this like a month. So 1 month in, and from what I heard, it's not an easy thing. Like, it takes years. But I'm just skipping all that. I'm just gonna skip all that. I'm just gonna start doing it. I don't even care. Alright, so your simulation is structured around these 3 principles. Component data, system logic, Yeah, I know all that. I tried this before. Okay, so would you like a breakdown? No, let's start. What would you recommend doing first? What would you recommend? I'm just gonna ask you, what would you recommend doing first? That's a great question when starting a project, especially one using complex framework like DOTS or ECS. It's best to build up the core functionality in small verifiable steps. I agree. I recommend starting with step 1. Define the agent and its data components. Implement the simplest system. Alright. The agent tag. First, we need the data structures for our agents. These must be structs that implement either iComponent data or iShared component data. The wealth component. No, I don't want a wealth component. Don't get too fancy with me yet. Implement needs and consumption. Let's not get that good. Let's start with, I'm gonna rephrase my first question. Let's start with, let's ask it if we can start with making, can we, I'll ask it if it would recommend starting with making an agent in ECS. I'm feeding it the question. I'm like, hey, would you recommend doing this one little thing? Yes, absolutely. See, I knew whatever I recommended, it would probably say. See, this is the one of the problems with the AI is it's very suggestible. And even though I'm new to programming, I'm new to game design, I'm new to ECS, I'm new to DOTS and all this stuff, I'm asking it, I know that I'm wrong. I'm saying, hey, do you think it's right? Should we make an agent first? Like, let's make one of these entities first? And it's like, yeah. That's probably not a good idea. I don't know, but like, I have no idea where to start on that, something like that, but let's see what it has us do, and we'll just find out. So it says, yes, absolutely. Starting with a basic agent entity and its components is essential, blah, blah, blah. You should create 3 basic ECS components to represent your individual agent. Remember, components must be structs that implement iComponent data. 1. The agent tag. This is a simple tag to mark the entity as a specific type of actor. This is useful for creating fast queries later. Alright, so it gives me an example of an agent tag. Wealth component. This holds the necessary financial variables. Well, See, it's getting too specific. I'm gonna rephrase my first question again, and you gotta. I'm gonna guess this is because it's saying like let's make a you said economy simulator. Let's make the agents with wealth components. It doesn't know that like I don't want to build a whole system around a wealth component. Maybe I'll not rephrase the question. Maybe I'll keep that, but I'll ask it. I say, so like maybe we could have a stats component or a let's see. Let's see. I'll say, should we? I'm gonna ask it. How vague? I know I'm not spelling that right. How vague should the components be when defining? Is it defining an agent or is it? Once you have the data, you need to implement the first piece of logic. Okay, well, let's say, because I want to know, because I'm thinking when you build a system in ECS, you know, you have your entities, then you have your components, which is like the stats on that entity. You need to build, like, if you want health, and you want intelligence, and you want wealth. So, but those are like three very different things, but they're both going to be represented by like a number that can have a variable. And I want to know if the AI would be able to tell me, a new person, if it would make sense to put all that information into one component or to make specific. So I gotta type that question out that I can verbally ask. It's harder with an AI, but let's see. So, how specific should components be? Should there be separate components for things like health versus health that would change frequently versus stats that change less frequently, like strength and intelligence and other information like money that change semi frequently. So like new to game design, don't know, but I'm just kind of like putting the logic together. You have an entity, a person. Then you have a component. The components are the data, or the and you have these. I'm wondering if I should build different components. And I'm just rewording this for myself in a sense. But you have a stat, a component, information like health. Oh, I got a phone call. Hold on. Don't go anywhere. Hello? Yes, speaking. Not too bad. How about yourself? Oh, no problem. No problem. Okay. Hmm. Yes, technically like in Marlboro, but it's like if you know the area, like right next door, pretty much. Yeah. Okay. Hmm. Well, it's kind of like one of those negotiating things. You ask for a high number, and then you know, see what you can do. I guess that's that's kind of the logic there. So in short, not particularly. Um, but I mean it's less than I made previously. But I'm also not. I wouldn't be surprised because it's like the role that you're looking for has a certain allocation. So I am. Yeah. Okay. Hmm. Okay. You said you do or you don't do the final. Okay. Yeah. Okay. Okay. Are you are you the branch manager or okay? Okay. Hmm. Oh, okay. Hmm. Okay. Let's see. This week, I'm assuming. I am available. Um, I usually head it like if I head into Keene, it's typically in the afternoon for personal stuff. Like so it may just be efficient for me to do something in the afternoon that works. Yeah, yeah. Pardon? No, that works. That works fine. That works great. Okay. All right. Okay. And you're in that. I think I actually worked in that building years ago when it was kind of like way back. Is that the same? You're across from Bensonwood Home. Okay. All right. So I'll see you there at 1 on Thursday. Okay. Did you have any other questions for me, or am I going to meet with you? Okay. And I may have caught your name, but I may have forgot it. What was your name again? Okay. Okay. Sounds great. All right. Thank you. All right. Take care. Bye. All right. Well, that was a sort of like an interview. It happens, right? I tried not to broadcast it, but it's a local distributor. Whoops, what am I looking for? It's just like a local distributor I was talking to, industrial products. But all right, let's see. So we're working with. So I'm trying to get the AI to do my work, do my job for me, which I don't even know how to do my job. Program. Okay, so I'm asking it a question. Sorry about the delay, by the way, but this is I'm doing more of a chill sesh. Nothing too fancy here. So I asked the AI where to start. And it said, oh, yeah, it gave me all this stuff. But I kind of want it to be more specific. I want to build the framework for this game. And and I've never finished a framework before because when you're doing ECS and dots, there's all these dependencies because the technology needs to be so efficient with the processing that it makes all these dependencies in the programming so that if it works, it's efficient, it's good, but it's hard to get it to work. For me, it's because I'm new. But all right, so I want to build. So I'm asking it, how specific should the components be? Should there be separate components for things like health that changes frequently versus stats that change less frequently, like strength and intelligence? Because those stats wouldn't change. If something has a certain stat, sure, it could change over time, but it wouldn't be like a constant monitoring thing. And other information like money that change semi-frequently. All right, let's see what it says. Yeah, it's pretty good at when you know what to ask it. It's pretty good. All right, that's a core question in data-oriented design. The general ECS rule is components should be as small and specific as possible to maximize performance and maintain code clarity. You should aim for separate components for data with different update frequencies, access patterns, and storage needs. Okay, storage needs. Yeah, that's another thing. So some of the components are not going to have any storage. Health, but so if you want an entity to have like wealth, that could have storage attached to it and stuff. So okay, so yeah, that makes sense on how to break it down. At least for starters, component information that wouldn't have another factor it would need to apply to, like, anyways, yeah. All right. Oh, let me turn my music back up a little bit. I had it down for the call. Let's see. So it's saying it's highly recommended to separate your data into different components based on the following criteria. Separation by update frequency, the most important factor. See, I didn't even realize, because I'm new, but I was like, the update factor, I would assume, would be an important variable. Data that doesn't need to update constantly can be in its own container of information that the memory doesn't need to look at unless a trigger or something initiates it. So I want to have thousands, tens of thousands of entities. I want a simulation here. To do that, you need to build it in a way that's efficient for the computer, and this is the way, Anyway, so it says component type volatile, health, energy, hunger. Changes every frame step. Rationale. This data is written to constantly, by keeping it small, systems that only need this data can access it quickly without loading irrelevant heavy data. Yep. Semi-volatile, gold, money, inventory. Changes frequently, but often only when specific action occurs. And then static, stats. Okay, alright, so it agrees. The AI agrees with me. Thank you, AI. Separation by access pattern. If two pieces of data are never needed by the same system, they should be separate components. Okay, that's good information. So when you have health is information. The only time you would put energy with health is if your systems that access that health information would also need the energy information for everything. Otherwise, keep it separate. And I'm assuming, yeah, I guess you would keep it separate unless literally every time you used health, you also used energy. I don't think that... Okay, so that makes sense. That makes sense. Okay. These two systems run independently. If you put all this data into one massive agent data component, both systems would be forced to load the entire block of data, even the parts they don't need. Okay. Which reduces cache efficiency. Separation by mutability. Read versus write. If you have a component that is only read by many systems, example, base stats component, and another component that is frequently written, health component, separating them helps parallelism. Multiple systems can safely read the same base stats component in parallel without issue. Okay, so say multiple systems can safely read the same base stats component. Okay. Only one system at a time can safely write the health component. Okay. For a given entity. By separating them, you reduce chances of a write conflict and allow systems to run concurrently. Okay, that's good. They run concurrently. So I'm trying to understand what that means. You know, like when systems run concurrently. I think what that means, I have no idea, but maybe that means you're running one system on one thread and you're running a different system on another thread. Is that what it means to run concurrently, or is that in parallel? I don't understand. I'm still learning. I could ask the AI, but unless I can apply that information right now, it's like I'll just forget it, so I'm not even going to bother. My brain runs in parallel, or it runs in mono. You know, my brain does not run in parallel or multi-thread or burst compile. It just goes in a one little string. A monoscript. Recommendation. Your agent, I recommend starting with at least these different components. Health component. Okay. A needs component. Okay. A wealth component and base stats. Okay, I like and then a job component. Man, this AI, yeah, I agree. That's exactly what we should do first. Okay. So this specific approach okay. Now it says, would you like to continue by implementing a decision-making process? No, we don't need to do that. Let's start with building the entity. I like the idea of the separate components. Before building them, should we make the entity first? It's like jumping way ahead. I was jumping ahead to understand how to build it. Order of creation. Oh, okay. See, AI's teaching me something. The order of creation. It says that's a very practical question in Unity ECS. The typical define the components. Oh, you typically define the components first and then create the entity. You don't build the entity the same way you build GameOps. See, when I started learning a month ago, and I still don't know much, but you start with the game object. You start with the game object. And you add, you give it instructions on how it behaves. Sounds like ECS is different. This is telling me you build the components first, the data structs. That's interesting. Here's the recommended order. The order of creation: components, archetype, don't know what that is, then the entity. Okay. Define the component structs. This step we already discussed, creating the structs that implement iComponent data, wealth component, needs component. This must be done first because you cannot define the blueprint without knowing the parts. Okay. Define the entity archetype, the blueprint. The archetype is simply a unique list of component types that define specific type of entity. This is usually defined once at the start of your code. ECS organizes all entities with the exact same archetype together in memory. Huh, okay. Okay, so an agent archetype is an agent tag, a health component, a needs component, and a wealth component. Or I'm guessing that will change as the thing evolves, but it's basically saying an agent archetype is the compilation of the components. And that's interesting because I'm already thinking ahead, which it's probably not, it's good in some cases, but it's like you could have different types of agents. You could have agents that have health, like an animal would have agent tag. You would have a health component and a needs component, but it wouldn't have a wealth component like it's an animal. It's just going around eating grass or running away or whatever. Those are things we can add later, like survivability mechanics. But okay, so yeah. And I'm gonna guess an agent archetype, you would build a different agent archetype for a type of agent that doesn't have the same components. But if agents have the same components, a human would have all the same components. You wouldn't have other types of humans with different components. So now it says instantiate the entity. Once you have the archetype, you can ask the entity manager to create thousands of entities that conform to that blueprint, blah, 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 blah. How to create the first agent code example. Yeah, but I thought you just said build the components first. See, the AI told me to build the components first. And now it's saying here's the agent archetype. Well, let's add this agent because it gave me the script here. All right, so and I'm gonna update it and let's create a new folder. Call it ECS in our assets folder. Let's make a new script. This script is going to be called actually let's not do this. Let's not do this because I think it was just I don't know why it was giving me this script. I don't know why. It told me to build the components first. And then it gave me an agent spawner script system. I guess it just wants me to see what it, I guess it just kind of wants me to see what the script is gonna be. It says, you'll do the entity creation inside a specialized eye system called a baking system or a regular eye system. If you are creating them dynamically at runtime. For initial setup, let's use the simple agent spawner system. We don't, no, let's not do that. I'm going to ask it, can we build the health components and the base stats and the job components? Maybe I should just ask it, can we make the health component first? Yes, absolutely. Let's define the health component now. This component will hold the highly volatile data that changes frequently, taking damage, healing. By keeping it separate, we are ensuring the systems dealing with damage and healing are highly efficient. I like the way you think, computer brain man. All right. I'm gonna rephrase. Okay, so what I'm gonna ask it. Which folder? Because the framework is important when it comes to this. Like saving the you have assemblies and things that need to be built, and this is not telling me how to build the assembly. So let's just ask it, like, I'll ask it, can you help me with the assembly and folder organization? I have a ECS folder in my assets folder. Should I save this script in there? Question mark. I'm feeding it the question because, yeah, so it says that's a crucial question, blah blah blah. Yes, you should save your ECS scripts with a dedicated folder structure. Here's a widely used recommended layout: assets, ECS, and then a runtime folder. Okay, and then authoring. Okay, so we'll make a runtime folder. It wants me to break it down even more. Create folder, and it's going to be called runtime. It also wants me to have a authoring folder. Okay. Assembly definition files. The most important step is creating the assembly definition files. These files tell Unity how to compile your code. Organizing your code into smaller assemblies significantly improves compile times and allows you to, it's what makes it so fast. What makes the program so fast. It says you should make 2 main assemblies within 2 in the runtime. Data and systems. Okay. He wants me to make 2? Okay. So, how do I make a assembly? I forget. Assembly definition. Okay, so create. Where's the assembly definitions here? Oh, here we go. Scripting. Alright, so this one's going to be called project.ecs.data. Okay. And then it wants me to make another one. And I'm not sure how this is going to work, but it says make another one. Call this one project.ecs.systems. Okay. Oh, it's telling me the purpose. The purpose of the data one is it holds all your component structs. The purpose of the systems one is it holds all your systems. Oh, smart. Okay. Okay, that's interesting. I didn't even think about breaking them both down like that, but that would save a lot of time in the processing side. Okay, so your project, blah blah blah. Alright, so it's telling me that in my data I have to reference the entities, collections, and burst. So I have to do. Oh, this window doesn't pop up on that, but I have to do Unity entities, I don't see entities. I don't see entities as a thing to add as a reference. Why don't I see why don't I see it? Do I have collections? I have collections, okay. Is entities in like the core or something? Burst, I need burst. So for some reason I can't find Unity entities in the, I'm confused. Now I'm confused. Why? I guess I could like ask it like, I can't find Unity.entities in the assembly as an option in the assembly references. I'm gonna guess the reason I can't find Unity.entities as an assembly reference is because it's like in another one, like core or something else. Okay, it says that's a very common hurdle. You can't find Unity entities as an option in the assembly definition. It means the necessary Unity package hasn't been installed. Well, I don't think that's the case. I have the newest version of everything, so. Alright, we might have to ask maybe like we have to ask a different AI or something, because it's telling me I don't have the package installed for Unity.entities. I wonder if I can even find it myself in here, actually. Like, in here, in collections. Let's see. Let's search packages. I don't know if this works, but let's just see. Entities. Oh, let's save that. So, no, not that. No, not that. I'm gonna try to ask another AI the same question. Why can't I find Unity.entities as an option in the assembly references? Could I actually not have the package installed? Because, like, I was doing this yesterday and it seemed to work. Where would that be? Project settings? Packages. Package manager. Okay. This isn't showing me anything. I thought it would populate here. Let's try package management, package manager. Okay. So we're in the package manager. Let's try Unity.entities. Oh, okay. In project, not finding it. How about in the unit registry? Oh, I don't have it. How don't I have it? I didn't have. didn't have entities. All right, install. Why? Because I opened a new project. I have to reinstall the packages. I didn't realize. Alright, you can't see, like, if... Oh, it doesn't share that window. When I open the package manager, but the screen doesn't show it for, like, for this... Yeah, but I did it. Alright, I hope I don't have to restart. Let's just see if it is an option now. It is. Okay. So news to me, when you start a new project, the packet, you got to reinstall the packages, I guess. All right. All right. So now we will include the agent health. Okay. So in runtime components, oh, we're gonna break it down even more. So like, it wants there to be another folder in runtime, one called components. And another one called systems. So it says assembly definition files. The most important step in creating assembly definition files. These files tell Unity how to compile your code. Organizing your code into smaller assemblies significantly improves compile times. See, this is like it wants you to organize things. I'm trying to think of an analogy, but it would be like if you were in a mechanic shop and you had bolts and you had 50 types of bolts, and you had like different thread counts, it wouldn't make sense to like say, all right, we're gonna have 2 bins, metric bolts and imperial bolts. Instead, it would be like, no, also inside those bins separate into like thread counts, because like you're the mechanic and you need a certain bolt. You don't want to be like fishing there trying to find, like, you're like, okay, well, I separated it into 2 different things. It's not good enough for this. That's the analogy that I am coming up with, where it's like, if you want efficiency, you specify so that that person that needs to find that thing doesn't have to search through the bin to find like it's in here somewhere. It's like you narrowed it down so much. In the past it was like, just put everything in, if it fixes a car, put it in that bin. And if you need to fix a car, dig around in that room over there. Dig around in that room. It's in that room somewhere. And then, like, as the technology evolved, it was like, hey, let's organize. And now we're at the point where it's like, literally just have like one spot for the one thing you need. So when you need it, you walk right into that room, grab the thing, and walk right out. I think that, maybe a programmer would say that's not what it's like. You don't know what you're talking. I don't know what I'm talking about. I'm just like I'm learning, and that's kind of how I see it. So it's like, all right. So it wants me to make a bin for components. So, all right. Your project components. All right. The most important step is creating assembly definition files. These tell Unity how to compile your code, organizing your code. Da, 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 da. You should create 2 main assemblies, runtime. Within your runtime folder, the components and the systems. Okay. Data. Alright, so it says okay, so the key setting with the data folder, don't know what key setting means, but it says it should not reference any other major assembly. This keeps the data layer pure and fast to compile. Okay, so does it want me to put an assembly in there that just references the parent assembly? Or is that what it wants me to do? I don't know. Okay, so that's the components folder. Basically, it's telling me your components folder should only reference, should not reference any other major assembly. Okay. Okay. And that's, from what I understand, that's a lot different than your object-oriented, which I didn't do very much of, but that was like, you define something somewhere. And I did not learn this very long at all. I did it for like a couple weeks, but you'd define something somewhere in some script. And then in a totally other script would like reference that thing. It would like, you'd define move speed or something somewhere. You'd define maybe something a little more specific. And then like something somewhere else would reference that. And that means like the program would have to like jump over there and like, I don't know, cache that. And then like continue. I could be way off here, but when I heard about this ECS and DOTS, I was like, I love this system. Programming and software development was like cool and whatever, but this technology, it's like perfect for my brain and efficiencies. I love efficiencies. I love like when I heard 200 times faster, I was like, I'm new to this. I'm new, but if I learn the newest technology, if I just jump way ahead, like I might gain some lost ground. I might be able to like regain the lost ground by like jumping ahead and falling on my face a lot of times, and probably your average person trying to do that would lose confidence. If like a younger person, I say average, I said average, now I say younger. What I mean is like someone that hasn't built confidence in their life, like just doesn't have confidence, would be like, this is hard. I'm not learning anything. I feel stupid. And this isn't for me, because they don't think they can do it because it's too hard. But it's like, lucky for me, it's like I've messed with systems before, and I know I pick them up, and in the end I'm like ahead of my peers. Even like at the last company I worked for, they said, don't mess with the system. This is our expert. This person in Virginia is our expert. They didn't know anything. Like after a couple of weeks, I was like, I was ahead of like their expert for years or whatever. And it's like, I'm not trying to like brag, but all I'm saying is I have like a confidence where I'm like, I can go into another thing where your average person would be like, this is crazy. And they would give up, even though they're just as smart, even though they're just as capable. They didn't have like a past experience where they beat the odds. Even though they're perfectly capable, it's like, so like that's just something. If you're trying something new and it's hard, don't think you can't do it, because it's like anyways, that's it. I won't go too far into detail on that, but it's like in short, I'm just gonna skip right ahead, because I know if you just keep, I already know from past experience, if you just keep working on something, you'll figure it out. Other people, they'll be like, I've been doing this for a month, I don't know anything. It's like, yeah. Anyways, and then 5 minutes later, I'm like, I don't know what the hell's going on. What is this? I'm confused. I'm not confused yet. I'm going slow enough. In the AI, a couple months ago, I wouldn't be able to do this. In my opinion, AI has advanced so far, because I did try to do this a couple months ago, and I couldn't do anything. So actually, like, I really got to give most of the credit to the AI, because it's actually explaining things. It's like having the best professor in the world giving you direct like focus, like personal, like information. And I know a lot, like, and I'll be the first one to say, a lot of the times it doesn't really know what it's talking about, or it's like you can't trust it. That's kind of the same thing with people too. That's something I learned in the higher educational system. Not at the time, but in retrospect, I looked back at what I was told, and I was like, they don't think they knew what they were talking about. I figured they did, but in retrospect, I was like, did they know what they were talking about? It was actually kind of shocking, some of the things. Like, a kid's not gonna, like a kid, but they're not gonna question teacher. I mean, sometimes, but it's very, like, I was one of the most questioning people out there. Yet, in my opinion, I was like not appropriately questioning the teachers, because it's like I just trust, you just trust, anyways. Let's see. So your project, ECS systems. Okay, so let's make our systems folder. Alright, so now we have our systems folder, and it says, so it's the AI is kind of using the term folder and assembly almost interchangeably. So I take that information and I'm kind of like, is it the same? Like, basically when you make a folder in ECS, and I have this ECS folder in my assets folder, I'm gonna guess that means inside that ECS folder, all the programming in there complies with the ECS, framework. Like, everything in there is gonna be burst compiled. It's gonna comply with the burst compiler. It's gonna multi-thread everything in there, but it's all gonna be like set up just right. And the AI is kind of using the term folder and assembly interchangeably. And I'm thinking that means a folder is an assembly. You still gotta like set it up, but let's see. So Because it's like saying your folder must reference it's saying your folder must reference this. But I thought it was the assemblies that reference things. It's saying the folder's referencing things. That's what I mean when I'm saying it's using the terms interchangeably. It's saying that folder must reference this. Okay, so does that mean I make it? I think that means I put this in there. I think it means I put the ECS systems. But wouldn't then this be called project.ecs.runtime.systems? Shouldn't, if we're following the naming convention, if we're following this like naming convention, shouldn't this, if I put this in the systems folder, shouldn't it be called ecs.runtime.systems? I probably should ask the AI that, but I think I gotta take a short. I'll be right back in like 5 minutes. Not even 5 minutes. I don't know if anyone's even watching, but we're doing problem solving. I'm just putting out my thought process out there, and if it helps anyone, I don't know. Anyways, I'll be right back. It's a good cold brew. I just discovered cold brew last week. I didn't know you could just brew your own coffee in your fridge. It's freaking amazing. I'll be right back. Where were we? Where else was we? Let's see. So, I was in a naming convention, I guess, and trying to understand assemblies. I think I might have the AI try to kind of explain that to me because it's pretty good at that. So I'm going to ask it. Alright, so I am building the assembly. Or I'm building the, is it called the assembly? I'm building the assembly for, no, I'm building the folders. Should each folder, and then I'll list them. Assets, ECS, runtime, assets, ECS, oh, well, runtime, systems, and components. So I'm building the folders. Should each folder, comma, should each folder have its own assembly in them? And I'm also going to put that. And I'm also going to ask it about the naming convention. And should they be named project.ecs.runtime, project.ecs.runtime. Oh, system. So this one could be systems. Dot components, and also the last one. Should that be named? I'm being very specific when I ask the AI questions because I probably don't have to be, but when I do, it gives me a very specific answer, which I appreciate. Especially when you're like learning. And I think the AI even realizes when you ask, like the AI is pretty smart, when you ask it a newbie question, it's saying this guy is a noob, let's give him some extra information. So let's see what it says. It says, that's a great question regarding assembly organization. While you could put an assembly in every folder, the best practice for performance and dependency management is to be more selective. And then it says, here's a recommended structure for your project focusing on the minimal and most effective separation. So, it actually tells me not to put an assembly in the parent folder, the runtime folder. It's saying don't do that. And it even gives me the rationale. It says the rationale for not putting an assembly in the parent folder is that this container it says this is a container folder. Creating an assembly here would clump the code all together, defeating the purpose of separation. Oh, see, thanks AI. And that makes sense. That actually makes sense to me. And yeah, it's saying don't do that because that defeats the purpose of separating them. Okay. And then it says in the components folder, yes, put an assembly in here. Okay, which I'm going to do right now. I'm going to put my data assembly in there. And it says the rationale for that is this assembly holds only the component structs. It should reference almost nothing, making it compile extremely fast. Okay. and then and then it says yes, put an assembly in the systems folder, because this assembly holds all your system logic and jobs that it must reference. Okay. My Unity decided to compile for some reason. Don't know why. Alright. Alright, so that makes sense. Things are so far so good. Things could get out of hand very quickly though, because this is, as far as the name, it says recommended naming convention. Your suggestion is excellent, but you should refine it slightly to clearly indicate the code's function. Ah, okay. The code's function. That makes sense. So it says, it's saying the systems, or wait, where was it? It says the components. It's saying the reason it's called .data is because basically because of what it references. Entities, collections, and mathematics. Okay. The systems, that's going to represent your economy data, entities, and burst. Okay. Alright. That makes sense. That makes sense. I'm putting it together. It may seem slow to your average person, but it's just I like to I love specifics and really understanding a system, and that is a detriment in a lot of cases. I've been told I overthink things, I do this and that. And then, but this is like perfect, for, you know, like, if you're that type of person, this is probably, perfect, because my hyper specificity is not a detriment when working with something, especially like in programming in general, but it seems like specifically with a data oriented technology. Anyways, okay. Alright, so I asked it a question and I think I jumped ahead a bit. So let's roll back to back here. Okay, so they wanted me to do the packages. They wanted me to add references. Systems file. In the systems file, it wanted me to reference utilities or entities in the reference file, or the system in the systems file. It wants me to reference entities, which I had to download. It wants me to reference. So far, that's it. Okay. So the systems file reference entities. It told me somewhere what it wants the data to reference, but I have collections, burst, and entities for the components folder. So I'm just reiterating here. This assembly in the runtime components folder wants the scripts that I put in here to reference collections, burst, and entities, which I don't even really know what those are yet. Like I think Unity Collections is like the base, like it's like the base definitions of things, like what a struct is, you know, like I think. And burst, I don't know what that entails specific. I'm not actually sure. I'm sure I'll figure it out eventually, but all right, let's go to scroll down. All right, so I'll just tell it. Oh, I think I jumped way, or okay. I've added the. Oh, so it's asking me if it says now that the structure is clear, we can proceed with defining the next component. Would you like to define the base stats component? Yes. Yes. I'm just gonna say yes. Alright, so the base stats component. It says this component's crucial because it holds the less frequently changing data. And it defines the fundamental capabilities of your agent. I like the sound of that. This thing knows what I want out of the info. Alright, and then it gave me a script here. It says this component holds the intrinsic attributes that affect an agent's success in work, trade, and survival, blah blah blah. Now, it's kind of populating the stats that it thinks I want. It thinks I want strength, intelligence, risk tolerance, and a speed multiplier. What stats do I want? Because I'll probably let's see. Well, let's make the script first. Create the script. We're gonna name it base stats component .cs. Alright. Now we'll open that. Reload. Okay. How big does this get? Alright, so now it wants me to do this. Mathematics is not... Wait. Is it because I'm not using any of the mathematics? It says the namespace mathematics does not exist. Does it? Okay, well we gotta add it then, right? Mathematics. Oh, I don't have. It's a package I didn't install. Alright, alright. So I noticed when I looked at the script, this mathematics is like it's gray and it's not accessible. I think since I made a new project I have to get this apparently you got to re-download this stuff. All right. Math. All right, let's wait, it says it's installed. Why does it say it's installed? You can't see the window, but it says it's installed. Is it because I misspelled math or something? I guess so. Alright, there it is. I added mathematics to the assembly reference even though the AI literally didn't tell me to. I kind of wish it I mean that seems like kind of obvious, right? Alright, so now the script looks no errors, but are these really the stats I want? When it comes to this economy simulator, which I just want entities that automatically decide on their own what the like how to make money, how to, like, just like AI. I bet, like, basically when you have a like a civilization or something, and you have like the civ, like AI for civilizations. I literally want I want each individual to basically be an AI. I want the individuals, and I want thousands of them. You might say, well, that's crazy. Well, that's why I'm doing it in dots. That's why I'm doing it with something like this. I want thousands of little individuals making their own decisions on what to do. So as far as stats go, they kind of really need a lot of stats. But for starters, we probably don't need a speed multiplier. Probably don't need risk tolerance. I mean, eventually, but for now, what component would I probably use first? Probably the first system I want to set up in this game is literally just like getting food, like just having the entities get food or farm, basically. So that would require, I guess, you know, I'll just do strength, intelligence, and dexterity. Why not? And I'll tell the AI that's what I did. I'm not doing what risk tolerance and speed multiplier. Alright, so now let's save this. Okay, that's a great start. I basically just, because like AI has like tokens, and it gave me a script that I didn't particularly think was perfect. So I took its script, modified it, then when updated the question that generated the script, and put my version into it. So then I think my logic here is that the token that generated that response doesn't exist anymore, and because I don't want it to I want to keep working with this one AI because it's going to understand my project the best. Because in theory, it's been working with me on it since the start. So anyways, that's why I did that. So let's see if that worked. It says that's a great start. It correctly uses all the stuff because you did it, but it says it correctly uses the struct and implements iComponent data. I noticed you have dexterity listed, but your description suggests its purpose is related to risk tolerance and trade decisions. In a typical, so it doesn't like my changes. It's telling me that it's, even though I erased its last conversation, Alright, so I'm going to edit my question again. Because I kind of want to get it off of this idea of making this game complex to start. Like, you said you wanted to have them make trade decisions. Yeah, eventually. I know I'm not going to be able to implement that at the start. So, yeah, I got it here. So I'm going to rephrase my question and just say, hey, yeah, I got a script here that starts with the basics. Strength, intelligence, and dexterity. I gotta rein it back a little bit. It says here, I got the script here that has the basics to start. I know it's trying to help, but it's like, let's just start with like strength, intelligence, dexterity. Like, let's not get into this risk tolerance. Alright, so now it's saying, I noticed you have dexterity. Oh, it's because let me edit this. The AI is seeing its own comments. The AI is seeing its own comments. That's what's causing the problem. Sneaky AI, adding hidden comments. Because in theory, it's like, the AI says something. We have the ability to make the AI forget what it said. We can roll it back. But the AI is smart enough to know, like, hey, I can, it kind of like was reading these comments and saying, hey, I won't get into that. It's kind of funny though. Alright, it says, that looks great. The base stats component is perfectly defined according to the ECS principles. A simple struct implementing the iComponent data. Now that we have defined the key components for an agent's data layer, which is going to be agent tag, health component, needs component, wealth component, base stats component. I might have to rein that back and make it a little simpler because it's saying like wealth component, but it's saying like needs component. I'm wondering if that should really be where we start. Is like need, you know. This is where it gets a little tough with the AI. Let's see. You know what? I think we'll call it it's saying health component. This is where like the naming convention, it is kind of important because the AI is kind of actually being too specific with these components, in my opinion. Base stats, that's good. This base stats one, good. It's just going to be exactly what it says. It wants to jump ahead into these like. All right, I think I'll reverse this. After I give it this script, I'm gonna say, I want to save this what it said. This is very good. I'm gonna add that as a comment here, just for the heck of it. Oops. Alright, so we're going to have an agent tag. The volatile data should be called a I don't know yet. But the wealth component should just realistically be called an inventory component. Now these other ones, the data that changes. I'm trying to think. I'm really trying to think what this like higher level data should be, but it should eventually an end game. I guess an end game at the final version of the game. It would be like it would be their health, their happiness, their energy. It would be all those things. So that component of what would that be called? Shoot. My brain can't think right now. The AI wants to call it like a needs component, which kind of makes sense. It's like, but the needs are going to be defined by the result of this information, not by the information. Like the needs, so like when the health is low and the energy is low and these other things are low, I wouldn't call that the needs. The needs would be like the result of the system saying this entity's like health is low, it needs health. So like it will prioritize increasing its health. But the component that holds that health is not the needs. That's just the vitals. The vitals. The vital. It's called the vitals component. I like that. Vitals component. The vitals. That, I mean, there may be a better word, but yeah, let's do that. So now what I'll do is like, so I have these three components, which I think will be the good base for this: vitals, inventory, and base stats. Okay. So now what I'm going to do is I'm going to roll back what the AI just said again. I'm going to basically tell it, hey, here's what we made, or here's what I made, me, not you, this base stats component for the static data. Alright, then after that script, I'm going to say, now let's do a vitals component for the volatile data and an inventory component for the semi-volatile data. Alright. Alright, and let's update that and let it see what it says. It says perfect. With strength, intelligence, and dex. Now let's proceed defining the two components based on their volatility and storage needs. Vitals component and inventory component. See, we're really getting this together. I'm like... So far, I like how this is coming together. We're going to be separating the data by volatility, which is something I didn't really even think of until I started like asking the questions, really digging into it, and the AI told me exactly the technology and how it works. And now we're kind of setting it up in a way that makes a lot of sense. So we're going to have volatile data, semi-volatile data, and much more static data, separated. Alright, so it's saying defining the vitals component. So it says this data in the vitals component will be written to constantly by the systems, but will be written to constantly by the systems like the needs consumption system and the health system. So basically, when we do eventually build a needs consumption system and a health system, this vitals data will be what those systems watch. And that makes sense. And that also makes sense why we wouldn't need the base stats in there. We wouldn't need the inventory in there. We really just need the needs consumption to watch the vitals when we have a needs system. It only has to watch the vitals. So I know I'm repeating myself, but I'm putting it into my brain. I'm putting it in there. It's like when you bake a cake, you don't flash cook it. You don't flash fry it. You bake it slowly. Slow cooking is amazing. Don't flash cook. Let's see. So vitals component is written da 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 da. All right. I'm gonna clear my throat here. All right. So let's go to our components folder. Let's make a new script. This is gonna be our vitals component .cs. Okay, and this is this. So, all right. So this vitals component, it's the AI wants me to put hunger, energy, and mood in the vitals. That don't make sense. That don't make sense to me. Like, this should be health. Is health actually, like, should health be a vital? Yeah. Like, because I'm kind of thinking health could be considered a semi-volatile. Hunger, energy, and mood actually would change constantly. Constantly. Health wouldn't change constantly. So actually this might make sense. Maybe I should have another, like, vitals would be, or, vitals would be the much, like, maybe we should have two levels. One that has to be monitored constantly. I don't know. Okay, so it's basic. So the AI is saying we'll do the health component separately. Okay, that makes sense. And we should probably just call that the health component, and that could be its own separate thing. It'll be a fourth component, and that kind of makes sense. All right. For now, I'll keep this. This makes sense. All right. Inventory component. let's make ourselves an inventory component. Let's create. Okay. And that will look like this. Looks good. And, oh, it's actually telling me, oh, this is great. It's actually going to tell me how the inventory component is used. I like this. There may be other ways to set it up, but it's throwing me an idea out there. It's basically saying, unlike the I component data, you don't declare a standalone inventory component. Instead, you add the inventory item structure as a dynamic buffer with an inventory item to your agent archetype. It says, and I don't understand what that meant at all. I kind of got like 10% of that. It says, when you create your agent archetype, which is basically, I do remember what an agent archetype is. I do. It's basically it's assigning the components, the jobs, and something else that make up that specific type of entity. And you can have different types of agents, I think, that wouldn't use, because if you just have like one blanket entity for the whole world, you're gonna be there's gonna be a lot of like data that, like, well, animals don't need to track an inventory system. Just don't. So you have your different agent archetype for an animal. I still want the animals to have their own little economy too. I still want animals in this generated world still have hunger, still have, maybe they'll have a different type of survival mechanism that will not be as refined as like what I want representing the humans. But and I love this technology because it really lets you isolate that data. We'll see. I wonder how far this could go. I wonder how much you could, because like I was saying before, people do build AIs for games, but they usually represent entire countries. You know, like this country builds a building here. The AI is like, they build a building here. I want each person to be its own decision making, make its own decisions. We'll see if that can be done. We'll see. Let's see. So, it's saying when you create your agent archetype in your agent spawner system, you'll modify it. You will modify it. It says agent archetype equals state.entitymanager.createArchetype, and then you'll give it type of tag. Type of this. So, okay. You don't declare a standalone. Oh, okay. I think I'm getting what it's saying. It's saying, unlike the data, so like data like health, strength, intelligence, it's basically telling me with inventory it's different. With inventory, you don't you add an inventory item structure as, okay, because basically what it's saying is the data has to have a dynamic structure, because it's not just like a I'm guessing because it's like not just like a number. Intelligence would be like 5, 10, 20, whatever. When you set up an inventory component, you can't just say 5, 3, 1, 2. That's not like, no, it needs a dynamic buffer, it sounds like. Because you're going to be putting in like, you know, this thing has a sword or something. That's not going to... Eventually, you want... The way ECS works is each thing like that. A dynamic thing like a broken sword. A worn sword. At the end, it eventually will just be represented by just a number. It will just be a number in a whole series of math that computers are very good at doing. So basically, like, the AI is basically telling me, like, you want an inventory system. You want, and it kind of knows, like, that means a dynamic things to be components. So it's basically telling me, if I understand correctly, well, if you want that to be represented by a number, you gotta put that together a certain way. I think that's what it means. I think that's what AI is trying to tell me. Because if you noticed, all the systems we set up so far, it's just been like here, like if you look here at the vitals component, it's a float. Energy, it's a float, which is a struct, which is a number. It's a number. It's a number. It's a number. Inventory component. It's going to be an item ID. Okay. And a count. So I guess each item in the game is going to be represented by an item type ID. And I wonder, okay. I don't need your viewers. I already have viewers myself. Dang it. Oh, it's just... I want to delete these stupid these things. Advertisements. We don't want advertisements! Let's see. So I guess inventory item is going to be represented by an ID. I do want items to be dynamic. Alright, let's see. Let me see. Training system, blah, 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 blah. Okay, so... Alright, so I wonder if I should ask the AI a question about items. About the inventory system. It is explaining more here. So it's giving me an example of adding items. A trading system and gathering system would access and modify this buffer. Basically, it says dynamic buffer inventory item inventory equals state.entity manager get buffer. Okay. So adding 5 units of wood, assuming the item ID equals 1 for wood, would be inventory.add new item inventory item ID type count equals 5. I mean, that would be like the most, I'm guessing that would be like the most basic, like, which is kind of what, like when we build this to start, it's going to be some pretty basic add, add things. But eventually it's going to be like a dynamic amount of wood based on the strength, the skill. Skills. Oh yeah, that's another. We should add a skills component as a between semi-volatile and static. Skills. But maybe not yet. Maybe that'll be once because I want to build the framework first. Once we get the framework built, we can add and add. It's just how I see it. Once you have entities with basic things, with basic jobs, and they're able to do basic things, you can add in a system like this. It seems a lot easier to add because you're like, well, I want people to be able to, instead of farming, I want them to get wood. Well, you can add a job. You can add the the tree entities. You can add these, and then like build it within the same system. I don't know if like object-oriented programming is able to do the same thing like that. I don't know, but I know this can, or at least that's the perception that I have. So this is what I'm gonna do. I'm gonna try it in this. Anyway, so yeah, eventually we will have to add a skills component, definitely. Skills, yeah, and all right, I like that. All right, so all right, so what do we have? We have our vitals. We have our base stats. We have our vitals, and we have our inventory component. 3 components to start. I noticed the inventory component, okay, alright, so iBuffer, iComponent data. So I'm going to ask the AI something just out of my curiosity. iComponent data, I'm gonna just ask it because this is probably the noobiest question out there. Why I'm gonna say the struct for base stats has iComponent data and so like I'm going to ask the AI, any programmer out there is going to say I'm an idiot, but this is going to, like, I notice in the base stats components, this says iComponent data, and in the vitals, it also says iComponent data, and I wonder if they should be, like, different or the same. I just want the AI to explain to me, like, why are they the same, and why don't they have their own, anyway, so, and in the, it's probably a stupid question, but it's saying that's an insightful question, but part of me wonders if it's just like being polite. The reason both your static base stat component and volatile vitals component implement the same interface iComponent data is because they are fundamentally the same type of data structure in the ECS architecture, a pure data container with a fixed size. Okay, all right. Okay, that makes sense. The reason this is iComponent data in the vitals, but also iComponent data in the base stats, which isn't going to change as nearly as much as vitals change, is because it's pure data with a fixed set. That makes sense. It says, here's the breakdown of what iComponent data means and why your components use it. It says, iComponent data interface acts as a marker that tells the Unity ECS framework 3 critical things. 1, it's pure data, not logic. 2, it's blittable. Is that a word I've never heard before? It's blittable and stored in chunks. What does blittable mean? What does blittable mean? Gee, I don't want to look it up because then Google will know I'm an idiot. It says components implementing the, so 2 is components implementing the data must be unmanaged structs. They cannot contain reference types like classes, strings, or lists. And that ensures the data is blittable, meaning its memory layout is the same in C# and unmanaged code. This allows ECS to store the component data for thousands of entities contiguously in memory chunks. This sequential contiguous memory layout is what gives ECS its massive performance benefit, as it's highly efficient for the CPU cache. Okay. I'm wondering if that's a if iComponent data is just like a, is it like an actual function interface? Unity entities, base structure. I don't know. I am understanding a little bit better, but I am still kind of like in theory, could you just call this component data? I'm gonna ask it that. Or if it doesn't answer, I'm just gonna like ask like what would happen if you just called this component data instead of iComponent data. I'm just curious what it would say. And that might reveal, you know, asking these weird questions, you know. So it's saying it has a fixed size. iComponent data are designed to have a fixed size, 12 bytes for 3 floats. Oh, it's saying, example, 12 bytes for 3 floats, like strength, intelligence index. Whether you update that data once an hour or 60 times per second. So it's saying whether you, so if you update it once an hour, like you do with base stats as an example, versus 60 times per second like you would do with vitals, the component size and storage location in the memory chunk do not change. Okay, so that means base stats would have a data chunk dedicated to it based on how much information's in there. Vitals that's checked more frequently would also have like a data chunk, and that would just, they just wouldn't change. Basically it's saying they don't change based on how frequently they're checked. So you have your memory and your processing. Basically this is this is obvious at this point, but like now I'm kind of realizing how obvious this is, but the frequency in which you have to check the data, that's a processing thing. The memory, but the memory side, I guess it sounds like it doesn't really matter. You know, like base stats is going to take up just as much memory as the vitals, even though vitals have to be checked constantly. I guess that's the easiest way I could explain it. So I guess when it comes to memory, it's the it's just like the data. It's not how, you know, it's not the jobs and stuff. Okay. All right, so why it says why the volatility doesn't matter here. It says, and this, I think it's explaining exactly how I explained it. It says the system doesn't care how often the data changes, it only cares how the data is stored. Okay. Okay. And then it says you correctly separated them to allow systems to query for small relevant data sets. But since both fit the definition of a fixed size unmanaged data struct, they both must implement iComponent data. Okay. Alright. In summary, use iComponent data for any fixed size data structure, regardless of how often you intend to read or write it. Okay. So what wouldn't be a fixed data size? Like the population. That wouldn't be, like, you know, the population wouldn't be, I guess, a fixed data size. That would vary. But a unit's amount of intelligence, you know, that'd be like a fixed, or the amount of the amount of stats. Something that wouldn't change would be the how many types of stats a unit could have. It has 3: strength, intelligence, and dexterity. That number doesn't change. It's always going to be the 3 stat types. I think that's the way it's taught, you know. So in summary, use iComponent data for any fixes. And I think that's why these are all structs. That's why ECS uses, DOTS uses structs. Because it's like one less computation compared to a, a variable? You know, a variable, or something that could have, like a struct, it's like, look, you're getting this one piece of data, here you go. You don't have to do that extra processing to, like, understand what data you're given. You just already know, like, it's a struct, here you go. Anyways, okay. Would you like to move on to defining job component? No, I don't want to move on. I think I'm going to take a quick smoke break. This has been fun. This is I don't know, like, even though probably no one's watching, this is just so much better for me learning, going through at this pace, and maybe some people will get, I don't know, maybe they'll learn something too. I don't know, like, usually when you learn something from someone, it's like an expert. It's not a noob. You know, who's gonna watch a person? But actually, you can learn stuff from noobs too. You can, you know, like. Anyways, yeah. All right, I think I'm gonna take a quick smoke break. I'll be right back. Where was I? Where was we? Alright, so we built these 3 components. I should have like a notepad for these things like these, but I'll remember to add a later a skills component. That would be key. So now it's saying let's move on to defining the job component next, which is another fixed data component. Oh, which is another fixed size data component. Why is it? Oh, it's asking, would you like to move on? Yeah. Let's move on to the jobs. Yes. What should the first job be? What should the first job be? But they don't, the entities can't move yet. So how, I'm just curious, I'll ask it, like, I'm curious about job component, but the entities don't have the ability to move yet. They can't move. I think I'll I'm curious what it'll say here. That's a very good point. The job component's critical for the economy, defines how an agent earns wealth. I keep saying wealth, but no, okay. You're right that movement's necessary prerequisite for any job that requires physical labor. It's a very AI way to put it. Since we're focused on the ECS data model first, we can define the job component now, include the necessary movement-related components later when implementing the movement system. Okay. That's a good that's a good answer. I was just like, I was curious if like the job, I don't know. Oh, here we go. Alright, so it's saying the job component needs to, it's basically saying don't worry about the movement system yet. We'll work that out like after we build this like framework here. So okay. So it's saying the job component needs to categorize the agent and hold the static parameters related to that profession. 1. Define the job categories. It says we define the possible job types using an enum. I'm wondering if it gives a definition when I hover over. No. This makes the component easy to read and query. So then it gives it here, and it says define the job component struct, like that. Okay, so it's saying first we define the possible jobs, and then it gives that, and then it says define the job component struct, and then it gives this. All right, I'm gonna say great. I don't want it to start throwing, it's throwing in movement stuff because I asked it about movement because I was just curious like how you define jobs before like movement, and it's just, but now it's like throwing movement stuff in there because it thinks it's trying to like alleviate my concerns. So I'm just gonna say back here when it's asking me if I want to define the job component, I'm just gonna say yes. So that it doesn't get like corrupted by my movement question. It says, yes, let's define job component. This component is critical for the economy and simulation, blah, blah, blah. Alright, we'll start by defining an enum, and then it does that. It's funny, it's got like gatherer, crafter, trader, service, unemployed. Oh, so this is literally just It seems like this is literally just going to be a list of anything, any job. And by job, I think it means like, not like profession. I think what this is going to mean is like, not job as much as it's like activity. Activity. These are activities, a list of activities. You know, like, in these activities, I kind of like the idea that these are activities as opposed to jobs. In theory, I would, and I'm just kind of trying to figure this out, but a job would be more like a tag that an entity could earn, like a tag, like you're a blacksmith. You get a bonus to this or that. I think the jobs, I think this should be realistically called activities. Maybe I'll rephrase that. I'll say, yeah, yes, job components. I'm gonna rephrase this and see if the AI agrees that these are activities and not jobs. Yes, job components sound great. Would it make more sense to call them activity components, since activities can include a broader range of like things? Sometimes I get real specific sometimes. Okay, so it's saying it's giving me choices A and B. It says your choice will help Gemini. Oh, it's literally giving me 2 prompts because I'm helping the AI learn. It's saying choice A is that's a fantastic point, an excellent refinement to your economy simulation. Yes, calling them activity components makes far more sense than a job component. In a dynamic economy simulation, agents aren't just limited to one long-term job. They might be engaged in many different states: working, searching, traveling, idling. A single component called activity component can track the agent's current state, allowing different ECS systems to quickly query and process entitled based on what they're doing now. Yeah, I like that. Heck, one of the activities could be job searching. You know, like this entity is trying to figure out the most efficient thing it could do. You know, like it could do. Then once it finishes that activity, then it goes into the job. Then it goes into the job. All right. So defining the activity component, we'll define this component to track the agent's current activity using an enum and hold any parameters related to that specific activity. Define the activity types. First, define the possible activities. We'll put this in an enum in a separate helper file or within the activity component file. Separate sounds better so far, but let's see. So this would be the list of activities, and it's giving me these: idle, working, traveling, trading, resting. Okay. And then it says define the activity component struct. This would be the I component data struct and would be attached to every agent. And that would be, let's see. This defines the agent's current focus. So the activity defines the agent's current focus. And inside that we have its current activity and its progress. Okay. Usage in systems. The decision-making system, which we'll create later, would be responsible for writing this component, changing the current activity based on the agent's needs. Example, the vital component .hunger is low. Decision making sets current activity equals trading. Then the trading system would query for all entries where entity with activity and activity component .current activity equals activity .trading. Okay. And then it gives a summary of the agent components. With the activity component defined, your agent blueprint is now very robust. Agent tag, static identifier. Health component, the volatility of the health component would be high. Vitals component, activity component, wealth component, base stats component, inventory component, and it's telling you the interfaces. All of these interfaces, except for the inventory system, would use the I component data, which is literally just a piece, just a number. So literally everything so far is just represented by a number. No script, no this, no that. It's just going to be health 8. Computer's very good at remembering and processing like just numbers. You know, vitals. 42 for health, for your health, which is 1, or your hunger, which is represented by whatever. It's just all numbers. It's just all numbers. The inventory system is going to be a buffer element data, which is going to be dynamic variables. Okay, so that's all option A. Option B is saying, and this is back to my question about naming jobs activities. Instead of naming them jobs, let's name them activities. And it's saying option B is, that's a fantastic suggestion. You're absolutely right. Thanks. It says, in ECS, a component should describe the state of an entity and an agent's current activity is a core piece of its state. This broader term will make it easier to expand your simulation later. Exactly what I was thinking. Let's define the activity component and the supporting data structures it will need. And here it's giving me a list of these activities: idling, traveling, gathering, crafting, trading, selling, consuming, searching. Great. And it says define the component struct. I think it's exactly the same as this one. Well, except in this one it's saying it's time in activity. So in this one, in option B, it wants a timer to track how long the agent has been in this state. In this one, it wants a float representing progress, the progress. It's funny because in option A, it wants a progress, like it wants you to measure the progress, and in option B, it wants you to, it's like suggesting that you measure how long it's been doing the activity. I really don't know if either one, like I'm kind of like realistically, I would want the entity to do the job until a trigger, something triggers it to not do the job. I don't care how long it's been doing it. I don't care how its progress. It would be like, it's going to work until it's hungry. It's going to work until its energy is low. It's going to work until its vitals are hurt, like it's hurt. It's going to work until something threatening is in its field of vision. I would want to build the system in a way where it's like, it's going to work until something else flags it to stop working. It could be internal, it could be external. You know, it could be internal, like health, hunger, food, you know, whatever. Or it could be an external, something external. It's boss. Hey, get out of here. Doing a bad job. You know. So that's what I would want the activities to, entities would just do, I guess. So in that case, it would need to track the progress, I guess, because if an activity does, there would be certain types of activities. Some of them you would need to kind of track the progress, because it's like, well, traveling, if it's doing an activity traveling, then that would, like, it wouldn't just keep traveling until there's well, I guess one of the external flags would be it reaches its destination. That would be like an external factor. Okay, maybe I don't need to measure either, but anyways, systems will use activity component in two key ways: filtering and querying. The gathering system will query for agents with the activity component. Current activity, blah blah blah, is gathering. State transition. Decision-making systems will change agents' activity based on their vitals, and then it gives the same examples, which that makes sense. Okay, so would you like to continue implementing decision component? Alright, let's go with option A. Option A was more helpful. It's just longer. Alright, so first things first is option B did have some better suggestions, but option A had like more detail with its explanation. And I think maybe that's why Google wanted me to, you know, tell it if suggestions or detail is more important, you know. First, let's define the activities. Okay. Well, we didn't actually make... Alright, we didn't actually make these, so... we'll put the enum in a separate helper file. Alright, well, how do we make a... I'll ask it, how do we make a separate helper file for the... activity definitions? It says that's a good practice for keeping your code clean. You want a separate simple data definition for the component structure, activity component. Here's how you would create a separate helper file for the activity type definitions. Create a new folder inside components. Call it something like definitions. Okay. Create folder. We're going to call it definitions. Create a script inside the folder called activity type. Okay. Create script. Wait. Okay. Call it activity type. Then inside that script, we're going to do this. Does it not need... Okay. So this is just going to be a separate folder for the activity types. And in theory, this is where you'd be adding stuff. Right now it's got these ones. Alright. Then verify the assembly inclusion. So we need to go into the structure. Wait, do we have to add it to the assembly? It says it's automatically added. It says since you're placing the activity type inside the folder, it will automatically be included in the assembly that you previously set up, because activity component itself is also in the same assembly. Oh, okay, because it's just in there. It's just in, yeah. You can use the activity type without needing any special using statements. You don't even have to put any using statements in there. That's the first thing I noticed. You know, like, this is the first time I haven't seen a using up top. Just don't have to. Because blah blah blah. Using the definition in the component. Your activity component.cs script, which I didn't make yet. Let's do that. Create. Let's create our activity component. CS. Here's our activity component script. It's saying this script, which is this, will then reference the enum directly, which it looks like it is. This organization keeps your activity component file clean, containing only the struct definition, while your various activity states are organized in a separate, easily extendable file. See, I like the extendable. This is all going to be extendable. Everything. From, like, especially when you break it down like this. That's what it seems like. Still new, still learning, but now that you have components and now that the components and definitions are solid, are you ready to implement the agent spawner system that brings your agents to life? I don't know. Wouldn't I want to do the I guess we could work on the spawning system now. Yeah, let's do it. We didn't build the tags. We didn't build the agent tags yet. But, alright. Let's do it. Yes. Let's work on the agent spawner system. Alright, implementing the agent spawner system. Inside your systems folder. Okay. So we are in the runtime folder now, but now we're in the components. Now we're going to go to the systems, which is kept separate. Separate. Gotta keep them separated. It says create the new script, agent spawner system.cs. Alright, let's create that. Alright, agent spawner system. Okay. And then it's got this whole thing. Here's the agent spawner system. It's a nice thick boy. Let's see what this is. Alright, so we don't I think we don't have mathematics here. Let's add mathematics to our assembly references. That might change up some of these compiler errors. There's a lot of them. Let's just close this and open it. I guess close it and open it again. What are all these errors for? I don't understand. Collections. Yeah, do I not have collections? I guess not. Thought that was a given. Alright, now let's try. Alright, that's better. I guess we didn't have collections on the assembly references. Alright, so I think I'm gonna guess we're gonna also need to reference the other assembly in this assembly. I don't know. Man, I gotta take a. Okay, give me 2 minutes. Alright, let's see. So agent tag, none of these, well, let's start at the beginning. The agent spawner implements iSystem. Really? Does that mean it's just a number as well? It says declare the, so this one declares the archetype variable and holds the blueprint. Okay. And then it says we'll use a constant to easily change the initial population size. Okay. On create, this runs once when the system starts. And inside that it's going to have, this defines the entity the blueprint. This lists all the iComponent and iBuffer element structs. The agent archetype equals state.entityManager, and that's going to create archetype. This is the archetype so far. Tag, health, vitals, activity, wealth. We didn't make the wealth one. I told it not to make the wealth one. I guess the AI is sneaky, because I didn't want wealth. I just want the inventory. Well, I don't know yet. Anyways, okay. I guess that does make. I don't know. It's a lot to build the whole game in your head as you're building it from the start. Don't know. This ensures the system runs at least once in the next frame. On update runs every frame. On update. It says we only want to run it once. I'm guessing because there's an end. Yeah. Create the entities. Native array. Da, da, da. Create an entity, and it's going to create the entities with an archetype. Or no, it's going to create the entity manager is going to basically send in a allocator. Don't okay. This is kind of Greek to me, but I'm kind of understanding what it's doing. Then random, new random. I don't think I have random set up. I don't think I have random package yet. Maybe that's in mathematics. It says loop through the newly created entities and set their starting component values for each health. Random dot float between 80 and 120. So it's basically going to give them a random health. Realistically, I'd want it to be like, well, maybe not for health, but for different things I would want. Like, realistically, what I won't get too deep into it for now. I'll just go with what it's spitting out, which is hunger is a random float. I'm guessing between 70 and 100. Energy, a random dot next float 60 between 60 and 90. Mood is going to be 100. Apparently the AI says, hey, mood's 100. Sure, your health, sure you'll get random health, but you'll always have 100 mood. Activity is going to be 0. Wealth is going to be between 50. The gold is going to be between 50 and 200. Raw resources. I don't know what that means. They get raw resources of 10? Why? Why are you just giving away resources to these guys, AI? Okay, strength is going to be between 5 and 15. Later, I definitely want, there to be a sort of like evolution process as well, where something is spawned after certain conditions are met, and there will be like the parent statistics that contribute towards, an average with a random. So you take the average of the parents and then a random spread. So if the parent strength a 10 and a 5 have a kid, you take 7 and add a variable 7 with a distribution of 3. They could have anywhere between 10 and 5, I guess. Well, actually, yeah, you don't even have to average them out. Just take a random number between the two parents. But then eventually everything would get, if you did that, a random number between two numbers, given enough time, you wouldn't, everyone would just be the same number eventually. Everyone, if you took a random number between 10 and 5, and they had a kid, random number between 10 and 5, eventually everyone would just be 7.5. Eventually. You'd have to, so I'll have to think about, that's a problem for way down the road, but it's just interesting to think about. This is not just, I'm really thinking, I know it's super ambitious. First project, programming a game. First project, economy simulator with evolution and animals and all this, just put everything in there. Who cares? But I don't know. So far, it's this is possible. It's a possibility with this technology. We'll start with something simple, just a town of humans trying to get food. and I want them to see if they can make decisions between like food. It'll be like just simple, a farm where they go to get food, and something else. And I would want to see like their decision, you know, based on how that works. And then if that works, then we could just continue to add the complexities. But all right, let's see. So it looks like everything here is here. The AI is really getting fancy though. Like it's really just like we're already adding random numbers to their health. It's like, dude, like let me come up with the systems like that. Well, I guess it's trying to help. All right, so we're missing an assembly reference. I think I'm gonna guess the AI will give me the assembly reference down here. Well, it didn't, so I guess I'll have to ask it. So right now, I'll just copy this code in there. I'll just copy this. I'm not even going to ask it how to fix it. I'm just going to spit that in there, and I think it'll know exactly what I need. I just want to make sure, like, I have a theory on how to fix the assembly reference, but I'm curious what the AI says. Yeah, it looks like your agent spawner system cannot see the component structs which are in the data assembly. You need to tell the systems assembly that it depends on the economy data. Yeah, that's what I was pretty sure that's what it was. I just didn't want to like data. Okay. Save. So basically the assembly for the systems needs to look at the data. But the data, I'm guessing, doesn't need to look at the systems. Your data is just like all the stuff we were working on before. The systems is going to be like what spawns, you know, the spawning of it and everything. Alright, so let's see if that worked. Well, it didn't work. Let me close this. Let me open it again. Oh, I think I gotta put it. I gotta put it up top, right? Gotta put it in the using. Yeah. So then we put the using up here. I didn't do it either. I didn't do it. Does it have to? Does this economy sim data? Am I doing the right name? Should it be using? So. Let's see. I think it wants me to do. Why does it say economy sim? I never called anything economy sim. Now I'm kind of confused. It's just called project. That don't work. I don't know what to say it's using here. Oh, well these pop up now. Oh! It's just the stuff we didn't make yet. We didn't make a health component. We didn't make an agent tag. We didn't make a wealth component. The other things are working now. We didn't make a health component. Wealth component. I'm gonna see if I can get the AI to can we make a agent tag? I'm just gonna ask it if we can make an agent tag, because I'll make the agent tag. I'll delete the health component, wealth component, these other things, or just make them too, I guess. So in the components folder, we're gonna make a script. It's gonna be agent tag.cs. And that is going to be very simple. It's just this. And it's nothing in here. Okay. And I'm curious if that is going to... Now there's an agent tag in the agent spawner system. Health component. Maybe we should just make our health component too? Oh, can you make... I'll just ask it to make me a health component. And what else? A wealth component, I guess? I could do it, but I think I kind of understand how to make... These components are pretty simple for now. But, alright, so we'll create our health component. And that will look a little something like this. And then, does that update our agent spawner system? Yep, it's got a health component in here now. Now the wealth component, which I didn't really want to make, but the AI is not going to come off of this. It really wants me to have a wealth component. I mentioned economy sim, and it's like, oh well, we need a savings. We need savings in gold and raw resources. Sure. We can modify. It's not a final thing, but it's just to get the system, the framework built. Now, when we go back to the agent spawner system, which is in the systems folder, there is no errors. This is all clean as it, I guess, as clean as it could get. I'll probably later, what I'll do later down the road is just ask the AI to clean this up. Say, I don't want random variables, I don't want all this. Just make it cleaner for me or whatever. For now, it's fine. It's perfect, actually. It even has these comments. It puts comments in here for me. You know, these components: high volatility, high, medium, low, dynamic buffer. Which I don't know if we really... I would want to set up that inventory system. That would be step 2. Right now, we're all still working on step 0, the framework. Alright, so we got the agent spawner system. Alright. All right, so I'm just looking back. So now it's asking me to proceed with needs different systems. It wants to make these systems. It wants to make, let's see, the system I have now is the agent spawner system. It wants me to make a needs consumption system and a decision making system. I'm thinking decision making system. Let's do a decision making system, but should we call it decision making system? Because this system, I think should apply to any mobile, any organism. It's any organism. Or I'll ask it. I'm gonna say, should we have like I'm actually there probably should be different systems for different types of entities. So I'm gonna. I'm gonna say I'm pretty sure if I made entities like animals, they probably could use the same decision-making system as the human. You'd be like, well, what do you mean? It's like, well, because like they just wouldn't have the parameters. Or maybe they wouldn't be able to. I don't know. But the decision-making system that I want to work on now is going to be the one for people. But I just want the AI to confirm that with me. I'm just going to say, like, would animals use a different decision-making system? Human agents, animals. Yep, absolutely. Okay, so I kind of knew the answer to this, but I wanted the AI to kind of explain so that I can learn the system better. It says, yes, absolutely. Different entities, such as humans versus animals, should certainly use separate decision-making systems. And here's why. Humans, complex logic, complex economic and social choices should I work, trade, socialize. And those are going to query the activity component, the wealth component, and the base stats component. Animals, simple survival choices. Okay, so they're going to have a completely different jobs, activities. They'll still have vitals. They'll still have, but they'll have different component. Well, like that, and that's for down the road. I don't want to work on the animals now, but it also would help with the naming convention. This is because when you name something decision-making system, that's like a general. That's a generalizing. So all right, let's see if it. It wants me to now that I kind of told it like, hey, let's give it a name, a more specified name. It's saying it wants to call it the economic decision system, but it's not really the economic decision system. It's going to be individual decision making. It's going to be the I mean, I guess it should just be called the human decision system. I'm gonna roll it back. I'm gonna say, let's work on the decision-making system. But can we call it more specifically the human decision-making? The human... Now I don't even want to call it decision-making. The human motivation system? No. The motivations decision-making system. Now I don't like it's now I think it's too long. Human decision making system. Is there a thesaurus? Hold on, let me is there a word for decision making that's one word? Selection, determination, judgment, evaluation, human determination system, human evaluation, no, human choosing system, human assess planning system. Individual planning system. Individual planning system. I think I like that. Oops. Let me see how it looks. Individual planning system. It sounds a little weird, and it may seem like I'm really monotonous, but when you find the right word, the right name for something, it really makes this a lot easier, because then now I have the individual planning system, then I can have the animal planning system, I can have the, like a planning system. It's tough. These are tough. Yeah, I'm just going with that. Let's just go with that. Individual planning system. Sounds weird, but... It says, that's much more descriptive and accurate name for what this system will do. The individual planning system will be the brain of your agents, interpreting their data and deciding their next course of action. This system will run frequently, every frame, or every few, based on data it reads from the agent's vitals and wealth. AI really wants to keep throwing wealth in there. And realistically, it would be like the vitals. But anyways, okay. Individual planning system implementations. All right, let's go to ECS systems folder. Create mono behavior script. It's going to be our individual planning. These letters are so small. Planning system.cs. Alright, so we have our individual planning system, and this is what it... Wow, okay. It's really giving me a lot here for these systems. Alright, so This uses mathematics? Alright, so. Oh, I think it needs burst. I think what we need here is our burst, compile. I think the AI will know. It just has some. It's spitting out some of these assembly references for burst compile. I kind of already know how to fix that. We need to add burst to our assembly reference, or download it if we don't have it. Burst. All right, save. Did that fix some of them? That fixed like 90. That fixed everything except for this. Alright, so what's this? The needs consumption system. Oh, we didn't build that yet. Needs consumption system. But let's take a look at this. The individual planning system. It's going to set the system to update after the vitals need consumption system run. So they'll run the vitals need consumption. We didn't make it yet, but that will spit out. Will that spit out a number or a something? A number. Well, let's see. Hunger threshold 30. So on update, that means each frame. Hunger threshold, energy threshold, gold for food cost equals 50. The cost to buy food triggers the trading activity. Okay. Interesting. For simple parallel, so iJob entity is parallel iteration over entities. Oh, that's cool. So parallel iteration over entities. I kind of want the AI to explain that a little more. Parallel iteration over entities. Does that mean like you have I'll just say 100 entities, and you need to find out if which of these entities are hungry. Can you run them all at the same time? Like just process it all at the same time on the same thread, or something like that? Because like normally you'd have to check each one. Like the computer would have to process. Entity 1, hunger 10. Hunger 10 equals less than 20. Equals hungry. You know, like this is like, and now entity 2 does the same thing. Does it? Now I'm wondering if it could just check them all. Like check all entities simultaneously up to like the bit count of the data that they hold. Because like an entity is like it's just numbers. It's just numbers. Those numbers are just bits. So yeah, I guess I could just check. Okay, I'm still figuring it out. I'm still figuring this all out. Alright, so it looks like this is a thing. I don't really know what this is all going to do just yet. But we do need our needs consumption system. And I do like that. That's actually a pretty good name. Needs consumption system. Alright, so it says the AI is saying next logical steps for the individual planning system. what it's doing is successfully converts component data hunger is low into a directive activity type trading. It seems like a weird activity, like when you're hungry is to trade, but later I can fix all that. But it's okay, so it's showing me here saying like that is not the activity I would want to do if I was hungry. What I would want to do if I was hungry is to check if I had food on me. You know, like, does my inventory contain food? That's what I would want to check, you know, like if I was hungry. This is saying if vitals.hunger less than hunger threshold, then like this loop will start. Check if agent has enough money to buy food. And then if their wealth is greater than or equal to the cost of food, the activity activity.current activity is going to be equal to trading. Okay, so if it's hungry and it has food to buy gold, trade. Otherwise, work. That's funny. Otherwise, you work. Otherwise, your activity is going to be working. That's a funny, like, it's an interesting, I love. This is exactly like the framework though. Like I can look at this and I can adjust this to how I want the entities to behave. I find it funny how the AI sets it up though. It's saying, hey, if you're hungry and you got food, good, go buy food. If you're hungry and you don't have money, work. It will be fun to set up the complexities with like I really like to spend time setting up systems. I've always loved setting up systems, and I like complexities. I love economies. I'm just looking at this and I'm going, wow, like there's so much you could do with this. You can start at the beginning. The beginning for me would be like, if you have food, eat it. And then all the else, then you could look into buying food, or you could look into hunting, or you could look into these different things. You know, like these different things. I like this. So now it's saying, okay, all right. If your energy is less than the energy threshold, rest. And there's no other else. There's no other else here. It's just, hey, if you need energy, rest. The end. Default idle status. If no urgent need is met, if the agent is currently resting or trading and their needs are met, then so basically it's saying if the activity resting, if they're resting or this is or trading, or is that not equal to? Man, it's been a couple weeks and I forgot a lot of, like, I only learned programming for like 2 weeks and I haven't done it for like a month. So it's like this is like equal, this is not equal to is equal sign. This is equal to if current activity is equal to resting, or the activity is equal, or if they're trading, then you go into this idle. Oh, I get what is. As the program goes through, it's going to get to this and it's going to say, hey, start trading. The end. You know, then when the thing like goes through the loop again, so like, hey, you have this entity trading, next frame it's going to go through this again. And if it goes through these and it doesn't need to trade for its food, if it doesn't need to rest for its energy, then it's going to go to idle. If activity type is equal to idle and its wealth is less than the cost of food times 2, work. So basically it's saying if you don't have enough money to buy, like, is that 2 days, like 2 days worth of food, then you work. So basically it's saying, like, if you're idling and your gold is less than the cost of gold times 2. So if you don't have 2 days worth of food and you're idling, work. It's a great system. It's very I like how the it needs a lot more. There's a lot more sophistication to go into this, but I like how it's like, hey, it's showing me how the logic works. I don't understand all these different codes. I don't understand all these different things. But I can look at this and I can go, hey, I kind of know what it's doing here. It's saying, like, hey, if you're idling and you don't have enough gold to buy 2 days worth of food, you better start working. You better do activity type work. It's interesting. That's interesting. This is fun. Alright, so that's the script it gave me. The only thing wrong with it is the needs consumption system, which is probably what it's gonna work on next. Let's see what it says. Next logical steps. Working, resting, trading aren't implemented. The simulation loop requires the next 3 systems. Needs, a working system, and a trading system. I think with that, I might take a break. This has been very... this has been very interesting, very fun, and even though there's nothing, the game is nothing yet. If I hit play on the game, this is the... I technically still have a compiler error because I didn't build the needs consumption system. But I think it's been very successful first day one of developing a game. Day one of a game, and I have, so far, everything is compatible with ECS. And everything is compatible with dots. So this game is going to be it's all numbers. Very, if we build a simulation using this technology, we can have tons of entities. Tons of entities doing complex jobs with complex systems, because we're building it all just with simple numbers. Each one of these scripts is just like this activity component. It just spits out a number. It's not it's not a complicated script like a lot of these games do. It's genius. And thanks to the AI is like 10 times better than it was just a month ago. I tried to do this like a month ago, and the AI it was difficult because I didn't understand very well, and the AI was just giving me like sample. Here's a sample. Right now, this AI, I'm saving this window, and later or tomorrow when I start again, it's still here. It still knows everything we built together. It knows it's keeping in its mind all the scripts we built, all the systems and assemblies that we put together, what I'm using, and it's gonna help. I mean, it's doing a lot of the work, but in this relationship, I am the white matter. It is the gray matter. I'm relying on its vast amounts of knowledge and my creativity. Kind of like how our brains have gray matter and white matter. The gray matter is just good for keeping, like, storing all the information, and the white matter is that creativity, that, you know, that putting that information together to make something. So that's, I don't know, it's been interesting, but I'll probably take a break now. My throat, I haven't talked this much in a while, but I'm definitely going to get back into this and hopefully make a game. I love the economy simulators. I've always loved tycoon games, city builders, these things, and I was like, and I also like games that are sort of like where the economies. I remember when I was a kid, I think it was like, what game was it? It might have been Oblivion. When Oblivion was coming out, maybe I was an adult at the time. I don't remember. I'm old now, but I remember when Oblivion was coming out, they're talking about, there's an economy in the game. I was like, wow. Like, I remember the economy. There was like an economy in Morrowind, but you knew it wasn't like global. It was more like local. It was like shop owners would have like their own inventory and their own money, and when I heard about, Oblivion is going to be like a global economy, I was like, that's going to be so cool. But then, like, as you're playing it, you're like, okay, like, I don't really like feel the economy. I don't really, like, it's I don't know. For me, I had to play online games to get that real economy feel, because the economy was built by actual, like, people playing an online game. And a lot of them would be the economies would be kind of screwed up in a lot of those games. But, you know, like, just, what online game? I mean, people start sending me lists. EVE Online or these different games, they have an economy. It is tough to build an economic system. But anyways, what I want to make is a simulated economy. And eventually eventually I think I will have a player that you can do your own decisions, do jobs like the NPCs, do this, do that, do the trading. But you'll be in this system, nothing special. You're just a part of it, and you'll be able to. I don't want to get too deep into that right now. Let's just work on this framework. See if we can get it working. See if I'm just, see if it's realistic. I think it is realistic though. This new technology, if you're not familiar with DOTS, DOTS, take a look at it. It's really crazy, and it's new. And that's my logic, is I'm new to programming. I'm gonna start working on the newest technology. Get ahead. Skip ahead. You kinda have to. I mean, I'm trying to think of an analogy of like a similar sort of like I mean, what else? I don't know. I guess it would be kind of like being like, this is the analogy where I'm going to sound bad. I want to race cars. I'm going to go to NASCAR. What? But that's very sophisticated, complex, expensive, difficult to understand. Like, yeah. But I'm just going to jump right into the deep end. That's not a good analogy, because in this circumstance, I think this is going to work. I think we'll be good with this. It's the AI; it knows this stuff. But well, I might do some of this later, and like today, or I might wait till tomorrow. But I got time, so maybe later today I'm going to have some lunch. And it's late, but I figured the later the The longer you can postpone eating lunch, the better. Some might say that's not good, but I try to hold off as long as I can. All right, guys, it's been real. Definitely, if you're watching like this, you can follow. I do play games too. I don't just do nothing. I also do stuff. If you're watching this on the like a video recording on the VOD, you can still follow me. I mean, most people will probably find this extremely boring. Well, you can fall asleep to it. Just go to hey, you have problems sleeping? Watch me screw around with a framework for 4 hours. Alright, guys. Peace out. It's been real.